In this video, we're going to be talking about test plugs and isolation technology. What I want you to get out of this is, number one, the history of test plugs and the legacy tools that most of our industry is used to using. Understand a little bit about the sealing technology and the legacy types of tool configuration. And then we're going to dive into new types of seals and a whole array of different types of isolation and test plugs that'll help you solve far more of your isolation and testing challenges than you've ever had in the past. So let's dive in and we'll talk about test plugs. So test plugs really became popular in the 1990s, and most people who were around in the 1990s will recognize these types of tools that either had a barrel with O-rings or a shaft with O-rings. And the whole point of this tool was to create an isolated area, either to guard from LELs that were upstream during the hot work process, or to isolate a weld in between the two seals to enable you to perform a hoop hydro test to prove that the weld had integrity. And so you've had a few different tools and yet you're familiar with, as I said, the barrel style of tool and a shaft style of tool. Now, these were common tools that were available from a couple of different manufacturers and suppliers in the 1990s. One used an O-ring style tool, and the other effectively used a hockey puck. It was a slab of polyurethane. In both cases, these tools used compression to compress these rubber sealing elements to create an isolated area. Now, the basic premise in a compression tool is to compress that seal between two plates that induces a pressure in the rubber of 1.5 times the pressure you're trying to isolate. So pushing that rubber O-ring between two plates so that its rubber pressure presses out against the pipe wall at a pressure of 1.5 times the hydro test. Now, this was revolutionary compared to having to do full system hydro tests, but this was the 1990s. And there was lots of other technology that became famous and popular in the 1990s as well. The PlayStation 1, we had one of those in our house. The Sony Walkman, whether it was a cassette or the CD versions. The Palm Pilot. Here's an old favorite of mine, the text pager, and of course, the tried and true flip phone, the StarTech flip phone. All of these were all 1990s technology that we all came to know and love if you were in the 1990s. But we're now in the 21st century, and just like this technology, hydro testing and isolation technology has made leaps and bounds, and our options and our capabilities for performing these kinds of tests have also grown significantly. And the key message here in this century, as in every other century, has been use the right tool. But if you only know that you have one tool available, then you try to use it in all applications. And with the advancements in isolation and test plug technology, you now have many more choices. Just like you have many different configurations in your piping system, you now have choices and options in terms of the right tools for the kinds of applications that you're going to be trying to repair and to pressure test or to isolate. And the way that I want you to think about the difference between what was available 30 years ago and what's available today is like you see on the screen here right now. The old rusty wrench, just like the StarTech and the PlayStation 1, we retired those tools and we now have a whole wider array of tools for that space. And so we have the old wrench, or we have the Test Plug Toolbox, a much wider array of choices for the way that you hydrotest and the way that you isolate in all of your pressurized piping and all of your vessel modifications. And so as we move forward, we need to move past the old rusty wrench and onto the Test Plug Toolbox, a wide selection of different styles of isolation and test plug technology that can really drive cost effectiveness, that can improve safety, and most of all, inside of your turnaround and on your piping projects, will just dramatically improve productivity. And so this Test Plug Toolbox gives you a much wider selection of tools than has ever been available before. And we have spent the last 13, almost 14 years designing, procuring, and building a wide selection of tools. And the key point in the creation, the ideas in this innovation, is many of the tools that we offer today came from one source, one request, one need to solve a problem, to take on a challenge. And it came from our clients asking us to solve challenges for them, new and different isolation and testing requirements. And the Test Plug Toolbox was a natural evolution of all of those kinds of requests to solve problems. So why don't we dive in and start talking about 21st century isolation and test plug options that you have. So the first thing to think about is when we look at old technology, whether it was the O-ring or the hockey puck, the slab of polyurethane, those tools were primarily based on a compression, squeezing that sealing element between two plates. But as you move forward and learn more about different types of tools, compression still comes into play. But there are also options and tools that'll give you more flexibility that involve inflation and that involve pressure energization or self-energizing tools, or the combination of a couple of different types of tools. Let's dive in and talk about the first of those tools. This is the internal weld tester, or what we call the IWT. Now, on first glance, it looks like an updated version of that 1990s tool with two seals and an annulus in between, but there are a couple of very significant differences and changes that will really create value for you as the user. Number one, you will notice, is in this whole style of tools, from the smallest right up to 12-inch, it is one centering nut. You do not have an entire set of bolts that you need to compress evenly to try to center the tool and to try to compress the seal evenly. It's one central nut. Beyond 12 inches, it's a hydraulic nut that replaces that one activation nut. So that's the first simple, easy thing. It's much faster and much more effective to center and to install. The second thing that is significantly different about this tool is it combines initial compression and self-energization. What is different about this tool is the inner compression plates are not part of the body of the tool. They actually float and have an inner O-ring, so that as you introduce hydrostatic pressure into the test area, that hydrostatic test medium presses on those inner compression plates, pressure energizing the seals. And so this tool is designed to be primarily a schedule-specific tool, but also medium and high pressure. So anything from a low pressure 500-pound hydrotest right up to 5,000 and 6,000 pounds of hydrostatic pressure, this tool can get the job done. It installs quickly. It always gets a seal on high pressure applications, and its ease of use means that with a simple one-page, 5-step procedure, any of your people can use this tool quickly without any need for a special training class. It's literally a tool and a simple process to accomplish low, medium, and high pressure tests in one tool. There's a couple of other unique advantages of the tool as well. The entire seal assembly, because it sits on one central shaft, the seals are modular, meaning that for one tool body, 2 to 3 different pipe sizes are available and all of the pipe schedules in between. Why is this valuable? Well, this tool can be interchanged with different pipe schedules or even different sizes to be able to capture a reducing fitting or to address and seal across a transition and still have that self-energizing nature and self-centerizing tool. So the IWT is just a fantastic tool, high performance, easy to use, low, medium, and high pressure. What does that mean? It means you can get the job done quickly. You can self-perform a lot of these tests with a rental or a purchase tool, and it is just easy to install because of that self-centering nature of the IWT. Just a fantastic tool that incorporates modularization, self-centering, and pressure energizing to give you just a really great high-performing tool compared to some of the technology from the past. The next tool in the Test Plug Toolbox is the dual tool. Now, the dual tool uses completely different sealing technology. The dual tool is both a double block and bleed isolation tool, and it's a low and medium pressure hydro testing tool. It can accomplish hydro tests up to around 1,000 to 1,250 psi, depending on the size of the tool. These tools come in as small as 2-inch and as large as 48 inches and everything in between. It can be either a schedule-specific tool or a multi-schedule tool. So this tool can be used in 24-inch standard, 80, extra strong, 40, as one tool body to cover multiple sizes. And what's the compromise? Well, as you have to cover more gap between the tool and the pipe wall, you do lose some of its pressure capabilities. And that's why it's a low and medium pressure tool. But because it's multi-schedule, you have a lot more flexibility around ovality, around pitting, around obstructions. It can equally be good for transition pieces. The unique way that this tool works is that each of the seals is independently activated so that you can pressurize the back seal and the front seal differently and have one seal on a different size of pipe, as an example. It also has a back pressure monitor and an annulus monitor. Now, the unique thing about the dual tool, because it is inflatable and you can see the various input ports on the front of the tool on the screen, this can be activated with an umbilical, meaning you can attach wheels to the dual tool and push it down the pipe 10, 15, 20 feet, and potentially capture, isolate, and then capture a closure weld that you would normally have to sign off. So it gives you some more flexibility in terms of the use cases and pitting, ovality. There's a range of places where the dual tool is just a fantastic tool to have in your Test Plug Toolbox. The next tool is a variation on tradition. This is the Innovator multi-range tool, or what we call the MR tool. Now, there's nothing special or different about this tool compared to the tools of the 90s, except one thing. We have designed this tool to be a multi-schedule tool and to have a much wider range on the seal itself. So instead of having to play around with different diameters of seals and different hardnesses of seals, the intention of this tool in the MR range is to do medium and low pressure tests, again up to about 12 to 1500 psi depending on the pipe schedule to plug interference. But this tool has been fantastic on transitions, on being able to capture welds on elbows or on T's. It is great for getting around obstructions like an OLED that may be in the way for a sensor while you're still trying to capture that weld. We've had many applications where we've taken a Schedule 80 tool and gone into a Schedule 40 pipe and being able to capture, move past an obstruction, and then be able to perform the hydro test where traditional tools have failed. And the significant difference is really it's a multi-schedule tool, and the way that we capture this tool to be multi-schedule is by using a much wider and much thicker seal that has a much wider range of capability. And so the MR tool is just an invaluable tool on shutdowns where your as-built and your as-found piping is not always as stated. And so having the ability to deal with what you find when you cut the pipe open and having the ability to capture a range of isolations and hydro tests is really key. And another key thing to know about the MR tool is it is both an isolation tool and a hydro test tool in one particular tool. So again, just a lot of versatility in the way that this tool works. The HB High Performance Grip Plug. Now, we've all seen grip plugs for years. They have traditionally been a compression tool, and they have traditionally had a range of bolts on the front that needed to be tightened in a torquing pattern to compress the seal evenly. Much like the IWT, the HB grip plug is different. It is a self-centering tool. Up to 12 inches, it's one self-centering nut, so it's really easy to install. And because it's a self-centering single shaft tool, it expands evenly in one activation without the need for a cross-bolting pattern like traditional grip tools. So that's the first thing that's uniquely different. The second thing about the HB grip plug is it incorporates the same pressure energizing nature that we spoke about in the IWT tool. We use the self-centering nut to use an initial compression on the seal, but inside of the tool, again, it has a pressure energized plate so that as hydrostatic pressure hits the end of the tool, it transfers that hydrostatic load to compress the seal and to activate the grips. And so the higher the pressure on the hydrostatic test, the more rubber pressure is created in the seal, and the more grip is created on the grips so that the tool will not be expelled from the pipe because of a flawed installation. The tool is always responding both with its seal and its grip to the end pressure of the hydrostatic pressure. So as the hydrostatic pressure is increasing, the tool is getting tighter and grabbing more, making it a safe tool and a high performance tool relative to full system tests. Now, this is the HB reverse. This is the same HP high performance grip plug that we saw earlier, but this tool is designed to be pressure energized from the front of the tool. So same self-centering, self-energizing nature, but all of the physics are reversed. And this is great for installing down the pipe to bypass a flange or a reducer that may not need to be tested, or if you have a need to be able to isolate one part of the system from the part that you're working on, then you can install this tool into the line activate it, and you can test up against the front of the tool instead of the back of the tool, and still have that self-centering nature of the tool for installation, and the combination of initial compression and then pressure energizing of the seal and of the grips as you continue on with the use of the tool in the hydro test. The FTT is a variation on the reverse HP plug, but it's designed specifically to allow you to not just perform a hoop hydro test, but to also elongate the weld. And what we're using effectively is a reverse HP plug to isolate the line, and then we are using a valve stem that floats a blind flange on and bolts up to the front of the flange. So what this allows us to do is lock the tool in place downstream of the weld, perform a hydro test in between that is both expanding the weld radially, but it's also stretching the weld axially. And so we have certain clients whose specification requires this type of hydro test, and so the flange tension tester is our answer for those clients who want both a hoop hydro test as well as an axial stretch of the weld as part of their specification. This is the FTT tester. Now this tool is called the FTT-MR, or the Flange Tension Tester Multi-Range. And what we've done here is we've effectively designed a flange tension tester tool, but we have designed it with a significant angle of compression for both the grips and for the seal. And so this tool is designed to deal with erosion and as-builts in the field, so that Schedule 80 pipe that may no longer be Schedule 80 in thickness, this tool can handle those variations in the field because it's designed to both the grips to expand and the seal to expand across standard 40, 80, and extra strong, and be able to do those FTT style radial and axial type of tests. The flexi isolation plug. The flexi isolation plug uses the inflatable plug technology that we spoke about in the earlier videos, where we are inflating the seals. These are not compression seals. These are actually inflated with hydrostatic fluid. We're typically injecting 300 psi of hydrostatic fluid pressure into the seals. They are a wider seal, so they are a fantastic seal for dealing with ovality, for dealing with pitting, for dealing with transitions. Now, the tool configuration of the flexi plug is designed so it can do low pressure hydro tests and double block and bleed isolations around elbows, like you see here in this illustration. So here is an example of the flexi isolation plug going around an elbow, and as you can see in this video, you can see the umbilical in use, and the tool has a series of roller ball bearings installed to allow it to easily move not just down the pipe but around those elbows as well, with each of the inflation, isolation, and back pressure lines all available from outside the pipe. This allows the tool operator to push the isolation tool much further down than hands reach, and to be able to operate the tool fully and monitor all of those aspects of the tool while it's being used to isolate, and equally while it's being used to perform a low pressure hydro test. You can see here a close-up of the flexi isolation tool and the roller bearings that are installed. Depending on the size of the tool, for smaller diameter tools we're using these roller bearings. On larger tools we'll use a spring-loaded wheel housing in all of the same locations as part of the tool design. The HTT or hub test tool is at the request of clients who have been moving away from ring joint connections and starting to install either Greylock hubs or SecureMax hubs. And this is a combination of the hub clamp with a test plug to be able to do localized hydro testing when you are repairing or replacing hub connectors like the Greylock or the SecureMax connections. Generally a custom order tool, but of any size hub connection that you use. The hub connector can save you time on a turnaround, and it's just another one of those tools that you have available in your Test Plug Toolbox. The longbow. The longbow is another tool that came out of multiple client requests. This tool is designed specifically to act as an HB grip plug in a long radius elbow. What we had were a lot of requests from fabrication and module yards where the piping spools as designed were terminating at a long radius elbow, and so the fabrication shop or the module yard couldn't use a grip plug for the end of the pipe like an HP grip plug because it terminated at an elbow. And so what we did is we kind of sketched out the grip capabilities of an HP plug, and we took the miter mandrel concept in field machining for MPrep tools and combined them together to create this tool to be able to hydro test when your spool piece terminates on a long radius elbow. The energy isolation tool is a tool that came out of a client request where they wanted a double block and bleed isolation for welding, but they also had a concern because they had, in some of their piping configurations, they were only able to create a single valve isolation, and so they wanted to have extra protection from a double block and bleed that wasn't just about LELs, but was actually about also isolating the potential for energy. Meaning that if the valve somehow leaked or passed and it was more than LELs created in the line upstream of the hot work application, that the tool could be a secondary isolation to actual pressure. So what we've done is we've combined a double block and bleed isolation tool that has initial compression, and we've combined it with a grip plug. And in both cases, the tool is self-centering, so easy to install, and it's designed to be pressure energizing so that after you install it, it's a double block and bleed isolation tool. But if for some reason it sees any increase in pressure at the end plate of the tool is designed and rated for, in this particular configuration, of 3,550 psi of gripping energy pressure. So this is the energy isolation tool. I also call it the LF2 tool because I name it after the person who asked for it, a friend of mine by the name that many of you who are watching will know. The energy isolation tool was a request and a bit of a design idea between myself and Lyle Freeland, who is a long-time turnaround piping guy, turnaround planner, and many of us in the industry have known Lyle for the last 20 plus years. Well, this is the Lyle Freeland tool, the energy isolation tool. Again, another tool that came from requests from the field, requests from clients asking us to solve an isolation or hydro testing problem. And that's what the energy isolation tool, the LF2, is all about. Combining a grip plug and a double block and bleed isolation tool in one tool with self-centering for speed and for accuracy of installation, and also the added safety of it being a self-energizing tool to provide that added level of security when you may be running concern about an upstream isolation not being sufficient. Here's the energy isolation tool prototype that we built a number of years ago. As you can see, it has these two self-energizing seals. The end plate that you see on the left pushes and provides compression outwards against the pipe wall for the seals and for the grips. And on the right-hand side of the tool, you see that single self-energizing nut. The NTT, or nozzle test tool, is a tool that we started designing about 8 years ago, specifically for clients who were making modifications and repairs to pressure vessel nozzles and were trying to avoid having to hydro test the entire pressure vessel. And so some of these tools have been around for a while. There is a couple of things that are unique about the Innovator nozzle test tool. The first is that we are using that combination of compression and self-energization in the way that this tool works. So we initially set the tool against the vessel wall, and then as we increase hydrostatic pressure, the tool responds in kind. Each tool is custom built for the nozzle specific to your application, and so the backing plate that you see is compressed up against an exact replica of the curvature of the nozzle in the pressure vessel. And as a matter of fact, the entire tool, as you see it on screen, is a replica of the nozzle that we fabricate. And what this does is it, one, proves that the tool will work before we bring it to the field, because our way of validating that with almost certainty that the tool will work in the field application is because we've replicated the field application conditions in the tool body itself. The second thing that it does is the tool mock-up that you see, and the tool is inside of the mock-up, becomes its storage device. And so it protects the tool, and it is a specific tool for your application, so that we have certainty that when we go into the field and you are using this huge productivity and cost saving gain over a full vessel hydro test, that you have confidence that the test is going to be successful and that you'll be able to do this productively, safely, and cost effectively. That is the nozzle test tool. We have several dozen of these that we've built over the years, and from time to time we are able to modify existing tools to meet new client needs. But generally speaking, with the nozzle test tool, this is a bespoke, custom-built application for your specific nozzles, and so you want to give some lead time for design and fabricating and testing of the tool prior to your project. Here you can see larger examples of the nozzle test tool in play, and you can imagine how using a nozzle test tool would be a huge productivity and cost effectiveness approach compared to having to do a full pressure vessel hydro test or pressure test, depending on the test medium. When you start to understand the different seal configurations and the different methods of being able to create and install a whole array of different isolation and testing approaches, then the imagination can take off. And here is an example of some great innovation in terms of using plug technology to accomplish something that no one had ever really considered. This is called the valve removal tool, and it is a situation where you have a valve that is leaking or passing and needs to be changed out, but you cannot drain the upstream system. Now, the valve itself, we will often do some temporary leak repair to seal the valve, and then we can install this valve removal launching tube on the downstream side of the valve, allowing us to launch an isolation tool. In this case, it is a double inflatable for a low pressure application, but any style of tool can be launched through the valve removal tool. From a low pressure, medium pressure, or even a high pressure tool with grips can all be launched through the valve removal tool, inserted upstream of the valve, locked into place, effectively creating a new isolation point, and then being able enabling you to remove and replace the valve in question. So this is the valve removal tool. It's just an example of what's possible when you start to think about the different tool configurations and the sealing configurations that are possible with 21st century isolation and testing technology. Sometimes you need something simple, but highly creative. So this is the Ultra Twin G isolation bag system. The G stands for gas or vapor LELs. What we have here is a double block and bleed bag system with an annulus in between to be able to check for LELs in between the bags. It also has an upstream monitor to monitor the LELs and any pressure from the upstream side of the bag. It operates on an umbilical that allows you to inflate and monitor each isolation bag separately. Now, when you don't need to hydrotest and you are simply needing to do an isolation, this is an affordable and fast way to not have to carry, lift, and install plugs into locations where a simple LEL isolation, double block and bleed, is all you need. And so this is the Ultra Twin G isolation bag system. It has an inner latex bag and then an outer Nomex and Kevlar stitching with pull tabs so that you can pull it through the system where you need it and then activate it from outside the piping system. Another variation of the Ultra Twin is the liquid hydrocarbons Ultra Twin bag. And now this bag configuration has a 3-layer system where the outer bag is designed to be resistant to hydrocarbon liquids. And again, it operates with an upstream monitor, a isolation in between the two bags, and the ability to inflate and monitor each isolation bag separately, all operated with an umbilical to be able to provide double block and bleed isolations in potentially liquid hydrocarbon situations. Another variation of isolation is the Argo Purge bag. Now this tool is designed specifically for when you are welding on stainless and you need to use a shielding gas like argon, rather than using rice paper dams and other types of remedial isolation points to be able to create that dam for your shielding gas. You can slide the Argo Purge bags into place, fill them with argon, and then be able to regulate the amount of gas that you are putting in between the two bags to be able to quickly install isolations for shielding gas and to quickly remove them as well. There's a few features on this bag that make it useful. It has Nomex outer bag protection for durability with pull tabs to be able to pull it through the line. It has the flame shield ends, the reflective ends you see in this bag, reflect away heat that may be coming from the welding process to the bags. And in between, the sleeve that we have over top of the braided hose is called fire sleeve, and it protects the rubber inside of the braided sleeve from any heat or sparks from the welding process. And the combination of all of those features make it a durable and fantastic tool to speed up productivity and cost effectiveness on your stainless steel welding applications. Next, we have the Thermo Argo bag, and the difference between this purge bag system and the regular Argo purge bag is it's designed to work while under preheat. So the tool has got a variety of insulating blankets and stand-away features that allow you to install it for a purge, but also have the purge bag itself withstand your preheat temperatures. Hydrotesting takes pressure. And so part of your test plug toolbox needs to be the ability to quickly fill to bring your hydro test up to high pressure. And so what we've built here is a skid that has a high flow filling pump system and a manifold that allows you to quickly switch over to a high pressure pump system, all of which is self-contained so that you can do up to 5,000 pound hydro tests in both filling and in building pressure up very, very quickly. As you can see, what we've done here for simple applications is we've just temporarily mounted it on a trailer, and it has a 4-cube storage tank for your test medium that is all plumbed into the pumping skid, and it all has secondary containment, and you can simply hitch it onto your truck and pull it into location with the testing medium, whether that's water or glycol, and be able to fill the system and then be able to bring it up to pressure significantly quicker than with a lot of handheld tools that you might be trying to piece together to do this hydro test. We have about a dozen of these in our rental fleet, and they're available for our clients to rent as they have system hydro tests scheduled in their projects. No tests can get done without a test header, and what Innovator has done is engineer a series of engineered test headers for both hydrostatic and pneumatic hydro tests, pressure tests. The significant cost involved with engineering and then registering the design and then doing the manufacturing for a test header can be significant. On a pneumatic test, every single joint is welded, every single joint is RT'd, and these can run into thousands, sometimes as much as $10,000 or $15,000 to manufacture these. So Innovator has a stock of these that are pre-designed, pre-registered with ABSA, and are manufactured for both hydrostatic and pneumatic testing so that they are ready for you to rent and for us to come and use them on service jobs as needed. And we have about 24 of these engineered test headers in our rental fleet that both our people use on service applications and our clients, you, can rent them as you need them. When it comes to your Test Plug Toolbox, one of the simplest tools is often the one that can cripple you or slow you down. I'm talking about blinds. Whether that's a tapped blind flange, a paddle blind for isolating parts of your system, or a vented paddle. These tools are critical in system hydro tests. They're critical in blanking projects to safe out your plant. And when you don't have these tools at hand, they can have a significant cost and a significant schedule impact. Over the last 10 years, Innovator has built up a massive inventory of all 3 styles of blinds, tapped blind flanges, paddles, and vented paddles. We have somewhere around 80,000 of these tools in our yard available for rent as part of our complete Test Plug Toolbox for our clients. And so if you need them, we likely have them. There's not much else to say about the innovation inside of test blinds, except that availability is key, and Innovator has the largest supply of blinds anywhere in the country. So that wraps up a variety of tools in the Test Plug Toolbox. We've come a long way in terms of seal design, in terms of tool design, in terms of solving a lot of challenges for our clients in a lot of different ways with self-energizing tools, self-centering tools, nozzle test tools, flex tools that'll go around elbows, a variety of inflatable isolation products like the Ultra Twins and the Argo Purges, some more niche creative tools like the hub test tools, allowing us to help you hydro test Greylock and SecureMax connections, and crazy tools like the elbow grip plug, the longbow, and let's not forget the LF2 energy isolation plug that came out of the requests from our clients. More than half of the tool concepts that we have shown you and that we have come up with in our Test Plug Toolbox came from clients asking for help because they were told it couldn't be done. And so if you get one key message out of the conversations we've had around the Test Plug Toolbox, it's this. When everyone else says it can't be done, call us. We'll probably figure it out. Thanks, everyone. I hope you got some value out of this quick summary of the range of tools that are now available in the 21st century when it comes to isolation and test plugs. We're not done yet. We're constantly building and designing and coming up with new solutions, and maybe yours will be the next challenge that we address to help you become safer, more cost-effective, and more productive on your next isolation and testing project. Thanks very much for watching, everyone. Bye for now.